Welcome, everybody. July 19th, another Node Operator Roundtable, and I'll pass it over to Brian.
Excellent. Thank you, Daniel. Good morning, good afternoon, good evening, and good night to all of the Antelope node operators. Thanks for joining again. Today, we do have at least one known agenda item that I want to make sure that we cover, which is related to some recommended configuration changes and coordinating the process of testing those configuration changes, which is going to be facilitated by Eric and Kevin, who are on the call today. Before we get into that, I do want to have a quick open floor just to gather any potential topics. We won't go into conversation on those topics yet, because I want to make sure we have time to cover cover that primary item. But yes, any topics that folks have on their mind that they want to discuss if there is time available today. All right, I think we've given sufficient time for people to find their unmute button. So with that, I'm going to hand it over first to Eric. And Eric, you can sort of facilitate from here on the topic of configuration changes.
Thanks. Hello, everyone. Yeah, I did want to talk about some configuration changes. With a lot has changed. We've been doing a lot of work on Leap, and we've been doing some performance testing, along with seeing data in the live environments. We wanted to recommend some configuration changes. I posted them yesterday, but I'm going to go over them again here. The reason for the changes is we've noticed some transactions are bumping up against this 30 millisecond time limit that they have. In addition, we introduced the read-only transactions, and there's some specialized configuration settings for those. The purpose of these changes is to give us more headroom on transactions, so we don't hit that 30 millisecond time limit, and also to make the full use of read-only transactions. So specifically, we've got the read-only window time, which is in microseconds, and we're recommending setting that to 165,000 microseconds. And that read-only window is to support the read-only transactions. The other change that we're recommending is the max transaction time to 151 milliseconds. And that's just 151 just in milliseconds. We'll be rolling these changes out to Jungle first. And as you guys may know, we asked Jungle to make some other changes that we're testing. And those were multi-sig changes for max transaction CPU usage and max block CPU usage. We're going to ask them, Jungle, to roll those back to match what's on mainnet. We want to test, incrementally, one thing at a time. Also, I think the multi-sig changes should really come after we've done these first set of configuration changes. So we're going to ask Jungle to roll back those multi-sig changes, roll out the new configuration changes, and then we'll see how things go. I think we'll want to test it for, not too long, because these changes look pretty benign to me and most of the other folks on the Leap team. But I'm thinking a couple days, maybe a week. So 5 to 7 days, what I'm thinking. After that, we're going to come back and ask the node operators here to roll out the changes. I think we're going to want to have these to be somewhat coordinated. And here's the reason why. If we're upping the time limit for transactions and not everybody has the same time limit, then some node producers would accept transaction while others could hit that time limit and then transaction not be allowed. And then you'd have different blocks and you'd have a little bit of weirdness and consensus. And we don't want to see that confusion happen at all. So we do want to roll that out. I don't know how often we are bumping up against that 30 millisecond time window for our transactions. I don't It's not too much. So I'm not worried about getting a precise rollout time for everybody. But that is a reason for us to have some diligence around this. And if we do want to go forward with this change after evaluating a jungle, we'll roll it out in a somewhat coordinated fashion. So I'll pause there. That is my spiel. Does anybody have any questions, any concerns, any other related things that you want to bring up? So I'll be posting the same note in the Jungle forum, and we'll have the discussion there, making these changes. And I'll get a timestamp for those and communicate that back in our forum.
So is there any benchmark results you can show for internal testing related to whatever you're changing already?
So, in this case, we because of some of the concerns that was, I think, brought last time or time before last about the consensus level max block CPU usage, so we're not recommending those changes at this time. I still think the chain could handle it personally, and I think that's something we could do. I think there's more concern in terms of like what kind of additional load that might put on history solutions and other things downstream. What we're specifically asking now for is just the the max, the subjective max transaction time per node. So it's not going to be illustrative in terms of like throughput increase or anything like that, because all this is the point at which you allow a transaction to propagate or pass speculative execution on a node, or ultimately then to be placed in a block. So it just gives that larger breathing room for EVM transactions. So it wouldn't be so much like a performance sort of increase in that regard, unless you're reading performance in terms of like the amount of CPU that makes it into a block, in which case, there's at least potential for that because of these larger transactions. So I think the more concern is just in terms of like, whether the subjective billing is sufficient for failed transactions that run longer than 30 milliseconds, right? So I think that's the major concern here, is the fact that, currently, as most people have it configured at 30 milliseconds, although I think some VPs actually have that slightly larger than 30 milliseconds on mainnet these days. But wherever that is, whether it's 30 or 50, I think somewhere around 50, then, if you've got a transaction that would happen to run for the full, say 50 milliseconds or 30 milliseconds, then that amount of time that they're subjectively billed for, and if it happens on a BP, then they're, it's potentially that amount of block time that is quote unquote wasted speculatively executing that transaction. So I mean, that's all kind of information you all know. So the big thing here, it's a long way for me to saying it's difficult that they kind of test these sort of scenarios in any sort of like controlled environment sort of testing. And so, that's why, we're wanting to like roll out a jungle, get a feel for it there. But even on jungle, right, I mean, we can realize that, it doesn't have the amount of load that, the mainnet has. And so, and like right now, we're watching mainnets having a huge amount of transaction flowing and that sort of thing. It's like it's during this sort of time period, like right now on mainnet, where we'd really get any sort of real sort of feedback for what happens to the network, allowing these larger transactions to flow through. I think the impact would be a small, the biggest risk here, of course, is somebody's doing a transaction that's designed to fail by using up all the CPU it can. And ultimately, that's going to fall back to our subjective billing protections for those types of transactions. Somebody can do that. There's nothing preventing someone from doing that, obviously, except for subjective billing. And so the only difference there is, the subjective billing, if you will, kicks in maybe a little bit quicker with the 150 milliseconds because they're on a quote unquote waste 150 milliseconds, or they're going to build for 150 milliseconds of subjective time as opposed to 30 milliseconds of subjective time. So hopefully that maybe addresses some of what you're asking there.
Sure. I guess the other question is why 151 and not 145 or 120 or?
Yeah. No, that's an excellent question. So we picked 151 because the on-chain consensus value is 150. So 151 puts us above the subjective limit and effectively gives us the objective limit on-chain. And the reason for that is just the fact that then you get you get a slightly different error message, which is the nice, which is telling you that it's the objective failure as opposed to the subjective failure. And so we thought for users that provides maybe a slightly better kind of indication that what's blocking this transaction is not any particular node operator's configuration, but really the on-chain consensus value, which I think at some point, maybe some point soon, we would be back talking to you about changing the on-chain consensus value. Now, we're not asking for that now, but potentially, we might entertain increasing the on-chain value as well. But certainly going from 30 to 150 gives us a whole different magnitude of what's possible, particularly, to be blunt, particularly in the EVM realm where, a lot of the transactions, because they are running in that environment are heavy. And so that gives them some more breathing room to run within those, within that timeline.
So currently I have the max transaction time set larger on the BP node and smaller on the Sentry node. So to prevent cases where, it uses up a lot of CPU time, fails, and then you get those empty blocks. So trying to catch them so they don't even make it to the BP. And that was set up when, Kevin, you and I were discussing the empty blocks, like 2 years ago.
Mm-hmm.
So with this recommended configuration, that goes away because everything is bigger now, right? So just wondering if you have any thoughts on Sentry node configuration versus the block producer node.
Yeah, that's a really good point. One that I haven't given a lot of thought to. Is the hardware the same on your Sentry as on your BP?
Yeah, pretty much.
Yeah, well, that's interesting. You might, because of that, you might want to consider, like on your API nodes, going with the 151, potentially, or maybe slightly lower on your API and your Sentry node, just to give that maybe a bit better feedback if that's what you're thinking, and that would be fine. Like if you want to leave those at say 149 or maybe 145 or something, and then allowing the BP at 150, 151, which pretty much which then gives it the consensus value of 150. So I think that's perfectly acceptable and appropriate. And maybe we could discuss recommending that for everyone as well, because you're right, that does give you potentially a better feedback to the user. The fact that that this failed it succeeded, so I've got pretty high likelihood that it's going to succeed on the other node. I will say with your nice transaction tracking though, users are able to actually see that as well. And, I would think that there would be very few transactions, at least initially, as people are getting used to the higher values. I would think there'd be very few that would be on that edge of that amount. You know,
yeah, I mean, this was back at the time where somebody was targeting trying to hit the 30 millisecond boundary, or 29 millisecond, right? And then it was just sometimes slightly over and sometimes slightly under, and the slightly over times you ended up with empty blocks.
Right. And so, you know, the whole part of the thought here again is that the subjective billing is our guard against this sort of, you know, badness, if you will. Right. Yeah. And so in a sense that it makes that more expensive in terms of, like, you know, each failure is going to cost them 150 as opposed to 30. So, you know,
but CPI is cheap.
Yes, it is.
Right. So, you know, we may need to look at the price of CPU on the network. Like, charge some real dollars. You know, gas fees on Ethereum are, you know, quite a bit higher than CPU fees on EOS. Like, if every failed transaction all of a sudden costs you $1, you know, that changes the cost benefit analysis of doing all these failed transactions.
Right. Well, and the other thing is, you know, you've got a lot more tools now with the subjective billing in terms of, like, you know, the window and how many, you know, how aggressive you are when they hit the 3-strike limit or whatever limit you want to put. That's now configurable as well. So, you know, you can put a 3-strike limit over a dozen blocks, right? And that makes that rather expensive if somebody, you know, is trying to get those failed transactions, you know, into your block and using up your block time.
Yeah, I've set it to 2 for now rather than 1, just to, you know, don't go too extreme to set it to 12. But
right.
But so far it's at 2.
Yeah, and those sorts of things that we may need to reevaluate when we, you know, when we roll this out. I mean, ultimately, we know, like, it's extremely difficult or impossible to really simulate what happens in like EOS mainnet in terms of the amount of different accounts and transactions that are flowing and the interaction between all of those. And so, yeah, we may have to, you know, we may have to pivot. We may have to get maybe even a little bit smarter about our subjective billing again. Hopefully, there's enough knobs there that we can, you know, we can react appropriately if need be. And then ultimately, you know, if we roll it out and all hell breaks loose, then, you know, it is a setting you can dial back if need to. We're hopeful that won't be the case, because, you know, we're hoping that, you know, EOS mainnet becomes a place for people to come and run their large transactions. You know, get those through.
Yeah. Okay. So I think the initial messages, you know, we're a bit short on these kind of details. So we're going to roll things out. Maybe we need to think about, well, what happens if things go wrong? What are the implications? What are the other settings? You know, these kind of messages to the block producers. This is a good time to educate them about the new stuff that has been included, which maybe they don't know about. So maybe a blog post that's longer than, you know, a 1-paragraph Telegram message would be appropriate.
Yeah, thanks. That's excellent feedback.
Yeah, so just to provide context, right? Because that was what was missing. It's like, hey, we want to make these changes. Okay. Sure. So that would be my suggestion.
And yeah, it's interesting on the going back to the performance benchmark testing. I think with the performance and the benchmark testing has really given us a sense of confidence about how much headroom there is. And I think we've also, with the performance testing, focused down on the changes that are needed to, you know, really increase our throughput, are those multi-sig changes and max transaction CPU and max block CPU usage. But going back to testing, like the per transaction CPU limits, we're not really doing failure testing in the sense of we're not really creating these long-running transactions and trying to run them against the node. When we go back and look at getting a variety of transactions to run, we're mostly looking at replay stuff. And of course, the replay stuff is only going to be the successful stuff.
Yeah.
So I think that's why we don't have as much of the empirical testing this particular change, but at the same time, we still have the confidence because based on the testing about how much headroom we've actually got, and knowledge that there's there's, I don't know what to call it upstream, but there's other configuration changes that are the real bottlenecks. And then this one won't be bottleneck. But there are some you have to watch out for unintended consequences. And, Matthew, that's why I'm glad you brought that up. I think a blog post is a great idea. I don't know how much really techie blog posts we do. And so that'd be a fun discussion for me to have with some other folks in ENF.
Yeah, I mean, the last blog post was about subjective billing, and our team wrote that one and posted it on the ENF blog.
So. Nice, excellent. More are always welcome.
It was ghost written, I guess. It doesn't have a name on it.
Secret's out now.
Yeah.
All right. Any final thoughts on this or next steps that we should be capturing? Hey. Well, Eric and Kevin, have you covered everything that you needed to cover in this topic?
Yep, I've been taking notes. I was going to post a little mini recap in the Node Operators Telegram chat.
All right. So we didn't identify other topics at the top of the call, so I'll have sort of an open call for that. Last call for topics to cover. Otherwise, we'll close early today.
Like talk a little bit about feature 5.0. That's some might relate what we were just talking about.
Sure. Take it away.
Sure. Okay. So we were talking about subjective billing there and empty blocks and the possibility there. One of the things that I'm excited about in the 5.0 release that is already merged in the main is the improvement to block times. We haven't talked a lot about this, I don't think. But so what we have in main, which will be in the next release, is that right now when blocks are produced, they're always started on the half-second interval. So now they may finish at various times, either at the very end of that 500 millisecond interval, although that is unlikely because most people are using either the default CPU effort amount or they provide their own CPU effort amount. I don't think anybody is probably running with 100% CPU effort on their block. They're certainly not for their last block because that causes havoc, but potentially they might be for the other blocks. So the default there is 80%. And so that, that gives a little bit of time where the block is stopped, whether it's full or not, giving it time to sign it and ship it off over the network. And then it effectively then pauses until it starts the next block time, right? Until that happens for each of your 11 blocks. And then there's the same sort of thing happened for the last block, except for there's, as you know, there's different configuration options for the very last block in terms of like how much time you allow it to run. So again, when you're producing a block, there's two limits that you can hit that then indicates that block is complete and it will ship it out over the network. The first limit is that CPU effort. So once you hit that time limit according to your CPU effort and block offset, there's two configuration options for the same thing. And it was mentioned, I think the last node operator meeting, or if not the one before that, that we really should collapse that down into one setting, and just have the one. Actually, that's already in main. I'd forgotten about it, and that's part of what I'm talking about. Actually, all those settings are gone, and all that's left is a CPU effort percentage that is taken, and there's no longer a last block setting. There's only the CPU effort setting that exists in main. I'll explain how that works now. So before, every half-second interval is when the block was started. Now what happens, and I'm sorry, then there's two limits that you can hit that then finishes out the block and sends it all over the block versus that CPU effort. The second one is the on-chain max of CPU blocks, which is one of those consensus changes that was changed on Jungle that we were originally asking you to change on mainnet, that we kind of pulled back on, at least temporarily for now. That's currently set at 200 milliseconds. So what happens is you can hit one of those two limits. If you hit the 200, which means that you've created a block that has 200 milliseconds of billable CPU time within it. So when you hit that limit, you can also hit the net limit as well, but I don't think we ever do, but you can. It's possible to hit the same limit for net as well. And it's set at 1 megabyte. So you can hit either one, but typically you hit the 200 milliseconds of billable CPU time for a block. So what currently happens on 4.0 and 3 and 2 and 2.1, all the previous versions, once you hit that 200 milliseconds, you finish the block and you ship it off, and you effectively then sleep. You do nothing. You basically just wait for the next half second interval. So that means that when you start your block production, you've got a number of unapplied transactions that are queued up, which often is the case. And I don't know what often here is, but sometimes, let's go with that word. Sometimes it's the case that you actually have enough queued up unapplied transactions that you can fill up your first 2, 3, sometimes the complete 12 blocks with transactions before you've actually drained your unapplied transaction. Basically, you can spend your entire round doing that, and that's done in those little chunks. Like you do 200 milliseconds worth and sleep for 300 milliseconds, and then you do 200 milliseconds worth and sleep, and then you do 200 milliseconds worth, and it goes in that round until the last block, which you have typically configured smaller than 200 milliseconds, and so it runs for 100 or 10 or whatever you got it configured for, and then it's done and ships off. So now what happens in 5.0 is we've changed all that. So instead of having the configuration for the 11th block and a different one for the 12th, now we have deconfiguration, which is the CPU effort. And the way this works now is that it starts a block, and if you've got enough transactions to fill up the 200 milliseconds of the consensus value of what's allowed in that block, it will actually finish that block, ship it on the network. That's all the same. The difference is in 5.0, it will actually begin the next block immediately. And it will potentially fill it up and ship it off. And if there's more, it will start the next block. And so you could actually, within, say, a 2-block round, which would be 1 second, you would typically do a max of 2 blocks. It's now possible to do 3 blocks. 4 blocks. I think that's right. I don't know. 3.5. You can do thirdly to 3 blocks, right? Yeah, 600 milliseconds. You can do those 3 blocks within that amount of time, and that keeps going. So you could actually finish all 12 of your blocks, assuming you've got all these transactions queued up ready to go, within 200 milliseconds times 12, 204, 2.4 seconds. You could actually finish your entire round of blocks and ship them off. And so how that comes into play with the increased max transaction time that we've been talking about is the fact that since you're doing all that early, if you happen to get a 150 millisecond failed transaction in that time, Well, all that's going to do is kind of push that out. It gives you a lot more breathing room because you're starting these blocks earlier. So if you waste 150 milliseconds on a transaction, let's say, well, yeah, that pushes everything out. Before, that might cost you almost the entire block. Now it's going to cost you time within that 12-second window. Hopefully I'm explaining it right. So it's less about wasting an individual block time as opposed to wasting 150 milliseconds out of your complete route, your complete 6 seconds of time that you're producing the block. And so, anyway, kind of want to describe how that's going to work with the 5.0 difference in the way blocks are produced. Sure. Questions about that?
Cool. I guess the only concern is if you have 12 150 millisecond failed transactions, then all of a sudden you're back to the old thing, basically.
That's true. I mean, there's certainly the situation, just like today, like, if you've got whatever the number is, a 30 millisecond failed transaction, then, somebody can eat up. If they're clever enough to get those 30 millisecond do nothing transactions into your block production window, then if somebody can queue up 1,000 of those, then you can.
So the only thing is you remove the last block percent time. Mm-hmm. So now with the new way of failing, we might miss passing off the block to the next block producer, because now we don't have control over how big that last block time is. Based on what you described. So if we have the failure case where we use up all 500 milliseconds of time for each block, then we keep the original schedule, and then the last block, well, maybe it would be empty because it all has the failed time, so maybe it wouldn't be that big. But it's still, we're missing that control for the last block to get to the next block producer. So in that scenario where you're using all the time, you still want that last block to be shipped early.
Yes. All right. Yeah, it's an excellent point. I'm gonna go look at that, exactly how that's working today. Yeah. Okay.
The Matthew stupid failure case that should never happen, but will happen. So.
Yeah. I mean, it's going to be much less likely, but certainly that is possible. You effectively push, because of failed transactions, you effectively push yourself back into the old schedule.
Yeah.
What happens with that last block? Currently, I believe, it's going to be according to the CPU effort, which is going to be probably configured larger than the way you would typically want for that last block.
Yeah, because like on some networks, we have that last block that 10% or something. It's really very tiny. Yeah. Because we need to get from Africa to Brazil.
Yep. Yeah, well, the nominal case, what this does, and we'll look at that. We can certainly address that by worst case putting back the last block configuration. But the nominal case though is that you're not going to need a smaller last block.
Yeah, exactly. So
all the time.
If that last block is scheduled well ahead, then we don't need this. It's only if we get to the 11.5 second time window, and then the last block is scheduled, then so it's really like time that the last block is allowed to be released rather than percentage of time. So always leave at least X amount of time for the last block to propagate to the network.
Yep.
That's the option you want.
Cool. Yep. Thanks.
The other thing that we discussed before on this is, currently tracking metrics in terms of how long it takes for block producers' blocks to arrive. And I provided a suggestion that, could we track the time that the block was actually produced? And I'm not sure, I think you took a note about that, but I'm not sure if anything happened on it. So there's the scheduled time when the block is supposed to happen, and then there's the time when it actually happened. And these are two different things. And so if we can measure the time when the block was actually produced, then I know the latency between how long it took for that block to arrive here. So then I can measure the latency between the block producers. Otherwise, you have no idea, because you have no idea when it was actually released, because you don't know how much failed time took up in that block production round.
Right. That's true today as well, although it's amplified with this new setting for sure.
Yeah, the new one is not, the current one is not so bad, because it's always within 500 milliseconds. So you're just checking the delta between the scheduled time and the block time. Now you don't know the scheduled time anymore, because the scheduled time is based on when the last block finished, which you don't know as a remote person.
Right. Okay. Yeah.
So it's just for monitoring. It's not really for, on-chain consensus. That's not important, but it's just peer-to-peer. When did this block actually get produced? All right. Well, that's great. I love this. Should make, being able to have lots of transactions faster. My only worry is that this is going to give a more variable experience. I don't know if that's right to users, because we're going to create all those blocks in 2.5 seconds, and then for the next 3 seconds there's no blocks. So you submit a transaction and you wait. However, they're probably waiting anyway because there's a queue. So
right, yeah, that's where we landed, in that it's actually not any worse, because the queue is already there, and you're only going to chew through it the exact same amount that you would be. It's just you're doing it sooner. So you're giving a better latency to the people in the queue, but giving the same latency to the people that wouldn't make it anyway.
Yeah. All right. Cool. I love having these discussions early before the release, so we can get those feedback in. So again, another opportunity for a good blog post on this. How are we making it better for transactions on the network?
Yeah, I like those call outs, by the way. Those are always inviting ideas for ways to highlight.
This is a great innovation, right? And I don't think we spend enough time talking about all the great things that we're working on in this tech stack.
Yep, agreed.
Okay.
All right.
To be on this.
Any other topics we should cover? Excellent. Well, with that, I'll hand it back to Daniel. Thanks, everyone.
Thank you, Brian. Thank you, everybody. And I just sent out the cancellation for next week. So no meeting next week, and we'll see you all again a week from next. Take care, guys.